Sara Erickson is a project manager that I met a couple, 3 years ago. I have huge respect for as a competent organizer of projects, as well as being intellectually interested and curious. I just want to point out that sometimes people are not curious enough, especially in this process of transitioning. So I respect Sara on many different levels, actually, just as a person and as an intellect. She is now a senior project manager with Charities Housing. It's a Bay Area affordable housing developer. And the goal here is to address the sort of misinformation, because the affordable housing community rightly has a strong voice in housing policy, being on the, the implementation end of everyone's aspirations. And Sara has done the work electrifying, and she can tell you the problem spots, the successes, the benefits and such. So you're going to have a professional, thoughtful discourse on this. Yay, Sara! Why don't you say hello to people? We'll test your microphone. I can see your slides, but I can't hear you yet. Still can't hear you yet.
Hi, Sara, it's Amanda. You might need to unmute yourself on your phone.
Hi, everyone. Can you hear me?
Yeah, there we go.
Yay! Little last minute tech glitches, but workarounds in this new COVID way of doing things. Thank you, Amanda.
It took only 1 minute. That hardly counts as a glitch. So, Sara, it's nice to hear your voice. I hope you're doing well.
Thank you. I am. Nice to hear you as well. Shall I just jump in and get started?
Yeah, you're important here. Roll with this. You're the affordable housing expert on construction costs who's presenting. You go.
Fantastic. Okay. Amanda, I'll just say next when I need to. So hello, everyone. Welcome. I am Sara Erickson, here to talk about all electric buildings and affordable housing and the cost benefit analysis that I have participated in, specifically on a project called Quetzal Gardens. And as I believe we all know now, especially everybody watching this presentation, electricity power is the most efficient technologies available and is the cleaner energy source. We are in a climate crisis, and going all electric is our future, if you believe in science. Next slide. Just so you know what you're getting yourselves into, this is a quick overview of the topics I'm going to cover. Next slide. This is my introduction of myself and my work. Previously, I was at Resources for Community Development, which is where I worked on the Quetzal Gardens project for 3.5 years. I am now with Charities Housing in my 3rd week, still onboarding. I'm a developer on the real estate team. I have over 15 years of experience developing and managing real estate assets, both market rate and affordable. I obtained my LEED AP designation in 2009, and so have long been a believer in integrating green building and energy efficient technology into the design process. I was delighted to find out that my new firm, Charities Housing, has committed to doing all electric on 100% of their projects. Our last mixed gas electric project is currently going through a construction closing, but all future designs for our buildings will be all electric, and there are several current projects we have already that are all electric. Gas is being phased out. It's not sustainable. The writing is not only on the wall, but becoming endorsed more and more by local jurisdictions. I see early adopters in affordable housing that have started all electric design, say 4 years ago or so, and more realizing that it is better to get ahead of the curve so that when it is mandated, which is happening now, they already have experience and can more easily adapt. Next slide. I'm going to be discussing my experience working as the primary and lead project manager on Quetzal Gardens, an affordable housing project owned by RCD. As part of the development process, we considered if we could make this project zero net energy. Listed on this slide were the main goals we pursued, and in future slides, I will go through the details of this cost benefit analysis. We did a formal procurement for an energy consultant, as RCD does. I had seen Sean Armstrong speak at the Beyond Energy Efficiency Conference in San Leandro in 2017, and really appreciated his focus on the financial costs and savings Ultimately, Sean had the most competitive proposal, so it was a win-win. He was who I wanted to work with anyway. Redwood Energy helped us to evaluate all of these decisions in a mindful and thoughtful manner. Sean worked for an affordable housing developer, I think as many of you know, as a project manager, so he knows the language us developers speak. And just because personally I am a strong advocate for green building, energy efficiency, climate change, etc., doesn't mean I can just push the technology willy-nilly on all of my projects historically. We are dealing with public funds and already expensive projects, so the most fiscally sound approach as a fiduciary for funders and investors is to ensure a cost-benefit analysis is done. Given that these cost-benefit analysis exercises have now been going on for several years on multiple projects industry-wide, I think there's a growing consensus in the industry that the financial benefit is there, or it is a relatively small premium to pay to go all electric, and it's worth it, which is why Charities Housing, where I currently work, made a blanket commitment to go do 100% all electric on all future projects. Even at Charities, I still will go through a cost-benefit exercise to evaluate the variety of all electric system choices that we have. Next slide, please. So you understand the overall project concept. Here are some salient details. The project is located in what is called the Mayfair community, catty corner to the Mexican Heritage Plaza in East San Jose. An interesting tidbit, the Mexican Heritage Plaza used to be a Safeway, and it was where Cesar Chavez did some of his first protesting for farm workers' rights. He also lived in the area. The Mayfair community thrives in part due to the influence and legacy of leaders like Cesar and Dolores Huerta. There are very vocal leaders in the community who are very wary of outsiders, so we had to go through a very extensive community engagement process. The whole point being there were a lot of eyes on our project. Our project was the first development in any urban village in San Jose, and for those who don't know, urban villages promote walk, life, play lifestyles to get people out of cars and on bikes, walking. It was the first major development on Alum Rock in a really long time, but after ours, there are now like 10 major housing projects in the works. Alum Rock turns into Santa Clara and goes into downtown San Jose where the financial district is. The Alum Rock BART station will be opening in the next 8 years or so, a mile from the project. There's a brand new bus rapid transit line along Alum Rock with a bus stop in front. Google bought land downtown, so this community is at extreme risk of displacement due to future tech workers wanting to buy cheaper housing on the east side and just take the BRT line to work. It takes 10 minutes. Although now with COVID, let's see what happens to the office sector as tech companies allow their workers to work remotely in the long term. All this to say, again, a lot of attention on our project and the cost of construction were continuing to rise back then in 2017, 2018. So it was even more important to do this cost benefit analysis to prove to funders we were doing everything we could to keep costs low. Back to the project is 70 feet high. It's the tallest building for miles, surrounded by low density, 1 to 2 story suburban sprawl. We have 4 stories of residential over 2 stories of commercial and parking. That's 4 stories of a hybrid of type 3A, type 5 over 2 stories of concrete podium type 1. Next slide. Here's a rendering and a view of the original site, so you can get an idea of the scale of the building and development. It's currently under construction in its 9th month, due to be completed next summer and fully leased up by wintertime 2021. Next slide. We got entitlements for the project in July 2017 and then started the schematic design process. During design development is when we really took the opportunity to analyze the costs and benefits of different building systems in an effort to see if net zero energy would be viable. Sean and I wanted to push the envelope to be as efficient as possible, but also be mindful of costs. Ultimately, I'm proud to say that the project ended up with an over 40% increase above code in energy efficiency, and it will be certified Green Point rated platinum, well in excess of the minimum points required. We unfortunately did not end up with a net zero energy project because it was not financially viable to a variety of constraints, but there were many lessons learned that if I were to do it over again and we were to apply those lessons learned, I'm confident that I think it could have been net zero. That unfortunately can be the impact of the learning curve that happens when you have so many green people to all electric systems on the design team. I will talk about our challenges with solar in future slides, as that was the primary reason we couldn't get to net zero energy. However, platinum rating with such high, over 40% above code efficiency was something our entire team was really proud to accomplish. So try and guess which one of these options was the most affordable option and which one we might have selected. I'm going to go through the cost breakdowns that we got from our GC for each option. Next slide, please. So all of these HVAC options are all electric systems, but different price points and effectiveness of cooling and heating spaces. When we first started the design process, we considered the least cost possible system, which was a through-the-wall package terminal heat pump, PTHP, similar to what is found in a hotel room. However, the problem was the through-the-wall PTHP does not insulate the outdoor acoustic noise pollution of the local environment sufficiently. And this Arama option put us in violation of San Jose planning indoor noise standards. The project lies at the corner of Alum Rock and King Road, both major thoroughways with high traffic. Alum Rock is actually considered a California State Highway, Route 130. Additionally, this was the first development in any urban village in San Jose, as I mentioned before, and the project was a gateway project to the Little Portugal urban village, and the design is stunning. Adding the through-the-wall PTHPs was going to distract from the beautiful architecture, so it was the least desirable option from an aesthetic standpoint as well. 630K was the lowest pricing option nonetheless, but we could not use it. After this exercise, and after it was too late to make design changes, Sean informed us of a new Arama PTHP, which came to market that had much quieter technology that would have passed San Jose standards. And I believe there was an option that was not through the wall to preserve the beauty of the design. So for those working on project designs right now, going this more affordable route is a very viable option, but it wasn't for us. So next slide, please.
And you will learn about that tomorrow morning at 10:40. That's the Innova and also the Olympia that's similar to the Innova, but Yehuda Folda, the general manager, company owner, he'll be presenting 10:40 tomorrow morning on that option. Thanks for bringing it up.
Fantastic. Other than the PTHP option, the other three options we considered were split systems. Option B was a split system with a heat pump and a traditional ducting. Getting away from ducting was also preferred for aesthetic reasons, but we were still focused on the cost. So next slide, please. Option C, this is what we selected as the final specification. This split system has a single wall-mounted fan coil with transfer fans, as opposed to what you will see in option D, which has multiple fan coils with one in each room. Next slide. These are the specs of the system selected. Cooling BTUs of 18,000 and heating at 19,000. We don't have one in every room like what is shown in option D. There's just one mini split system in the living rooms for the 1-bedroom and 2-bedroom units with transfer fans. However, in the 3-bedroom units, we added a second mini split system in the master bedrooms to ensure those larger units would be cool and hot enough for our residents. Next slide. Here is option D, which is 200K more than the system we selected. This system would provide the highest comfort. As developers, we need to be mindful of global warming, and that in future years, as we have more really hot days and more fires, that these buildings are designed to accommodate these heat waves. And AC has been a luxury to date, especially in the East Bay, I think, but with global warming, it is more and more becoming a necessity to be thinking ahead. These projects will last for decades, and it will be much harder and more expensive in the future to add HVAC systems than to figure out how to integrate high quality systems now. In retrospect, I would have gone with this system knowing where the budget ended and that we could have afforded it. At another property at RCD that finished construction in Walnut Creek last year, the HVAC systems that were specified didn't have the high BTUs that Quetzal Gardens had spec'd. Tenants were miserable and complaining during the hot summer days, suffocating in their units, especially during the smoky days during fire season, and they were cold during the wintertime. Property management had to provide space heaters and then cover the added utility costs for tenants. After the fact, the design team had to figure out how to add additional HVAC units only in the studios and small one bedrooms, and it ended up being a major headache and extremely expensive to add after the fact. And there were liability warranty issues as to who was at fault for this design flaw. The rest of the RCD development team was given instructions from the director of development to double check your HVAC systems and all of our other projects that they would be sufficient. And thankfully, because we did such a dedicated deep dive into this analysis, Quetzal Gardens specs were significantly higher than the Walnut Creek project and included transfer fans and ceiling fans. So we feel pretty confident that future residents will be comfortable once the building is occupied next winter. And an extra $200K spent upfront now to ensure resident indoor air quality comfort is pennies compared to trying to fix it after construction is complete. A lesson learned. Next slide. Here's a recap of all the pricing, so you can see the comparisons in one summary snapshot. Next slide. On to domestic hot water systems. I will go through the cost breakdowns that we got from our GC. Domestic hot water design took more time than HVAC to evaluate because of the relative unfamiliarity of heat pump water heaters. The design team, the majority of the design team, with the exception of Sean, was not very familiar with them. And the design team in total was like 15 people, like 3 from our GC, 2 from ownership, 3+ from architecture, 4+ people from the MEP consultants. We had Sean, we had our solar consultant, a lot of cooks in the kitchen, and we considered many alternatives over a period of months of discussions and cost estimating. I fortunately had the time to delay our design progress and do this exercise, but there are many other projects on tighter schedules who have trouble prioritizing this exercise, and then they just end up going with gas because it's just easier, right? It's easier than spending months trying to evaluate what the heck are these hot water heaters with heat pumps. But so these are the 3 options we explored. Next slide. So this was the second most expensive option. I learned from Sean that a centralized system, due to the circulation of the water, loses about 30% of its efficiency and increases hot water energy use by at least 30% over a decentralized system of tanks. This would result in needing a larger solar array. So adding that solar array added costs put this as the second most expensive option. If we had not added the solar array costs, it would have appeared to be the most affordable. So I'm glad we did that. Next slide. This is the option we selected. We attempted to consider maintenance costs as well involved in repairing a central boiler system versus individual water heaters. And central systems require routine maintenance. Typically, you need to hire a third-party vendor. Maintenance staff aren't trained to do it. When an issue occurs on the central system, all residents are impacted. So from a maintenance perspective and a repair perspective, individual hot water heaters seem like the best route to go. Time will tell in terms of, property management team was really nervous since they were not familiar with any of these systems, but ultimately they realized that we are in a time of adopting new technology and they'll just need to be trained accordingly. there isn't, RCD and Charities housing doesn't have a lot of data on the operational outcomes and maintenance issues and warranty issues yet. And I think most affordable housing developers don't, because we're really, most of us are in this design phase. Sean, being a pioneer in the field, started doing this so long ago, so he has access to a lot of properties that are in operations, was really helpful to get that data, and then also to be able to connect our property management teams to those teams to just talk about any lessons learned and feedback. Next slide. This is option C, and you can see that the gas infrastructure costs were greater than the boiler equipment costs. Our GC could not get a sub to price out a detailed estimate of the non-equipment related costs. So Sean needed to go and find some detailed comps. And so point being is that had Sean not went and gone and done that exercise, it would have appeared that gas was the cheapest option. And, you know, it really felt like the GC, they had a couple other all electric projects that were going on, and they were having some challenges during construction with them. And so I did get a sense that, you know, they weren't going out of their way to prove that gas is actually in the same ballpark as electric. Next slide. So here's a summary, and you can see that they all are very similar. And from a pricing standpoint, they're so close, we could have picked any of them. But ultimately, based on what I had just discussed before, the individual water heating tanks were the decision that we felt was the best for the project. If I were to have made a decision based on just the GC's pricing as the cheap gas is the cheapest option, it looked like we would have paid a premium of about $100,000 to go all electric. So, which in the scale of the entire hard cost for the project were $41.5 million. So that is really not a big premium to pay, especially when there's so many other VE decisions, 50K here, 100K here, to be made. We had an issue with being almost at capacity with our electrical load on the one transformer that we had. And so it's 50K to add an extra transformer, and I made an executive decision to do that just because it seemed like we were at risk with the systems we had. And so also though, the fact that electric vehicles are becoming more and more prominent in the marketplace, I want to be looking ahead to the future. I don't know if I'm going to be able to get to it. Looks like we're kind of have too much here to talk about. But on my Antioch rehab that I worked with Sean on, one of the reasons we couldn't convert it to all electric was because of the electrical systems and the costs involved to upgrade those. So in total, a worst case scenario of an added premium was $150,000 on this project. And when you look at the parking stackers that we put into this building, those are over $1 million in added costs that we didn't, you know, we could have avoided had we decided not to prioritize adding parking stackers. But in affordable housing, that's often like the biggest communities, their concern in the community is parking, unfortunately. And it's interesting to see, I think, a lot of developers that kind of like, because they need to get through entitlements and they need community buy-in, they're willing to add $1 million to add parking stackers, but there's resistance to going all electric. And I think Sean's estimates on demo, offsite, and site lateral costs are very reasonable. And so, you know, in reality, going all electric was the most cost-effective choice. And, you know, say that there's some wiggle room in the costs. A worst case scenario, it was a premium of $150,000. Personally, I think going all electric is a no-brainer, and I would encourage developers to think twice about prioritizing parking stackers and look at how you might be able to value engineer parking back $200,000, and in that scenario, you're offsetting whatever minor added premium might result with all electric. Next slide. So lessons learned is we started the cost benefit analysis during the design development phase. And I think we should have started earlier. It took us so long. And then there were some miscommunications that happened. We had wanted to wire the individual hot water heaters to the house meter. That didn't happen because of a miscommunications with MEP. And by the time we figured it out, it was too late in the design process to change it. But if we had started earlier, we would have caught that. And that would have been a huge help, because if we had taken the hot water, that utility out of the tenant's utility allowance, then the utility allowance would have been lower and rental revenue would have been higher, and we could have leveraged a higher loan. So it would have helped finance any upfront costs on, like, say, solar. So that was a big lesson learned. And the coordination, hands down, I think that's the biggest reason for resistance, why people don't do it. It is a lot more time consuming as people are learning about these systems, but I've done it once, so it's going to be easier, right? So that's what happens. It's and then I would encourage folks to look at kind of the UAs and QAC as a potential financing mechanism, getting those utility allowances as low as possible to increase rental revenue is a way to, as I said, leverage a higher loan, and that can be a meaningful way of offsetting any added costs, in particular on the solar part. And so the solar array, unfortunately, we should have started that in the schematic design, because we were too far along, and we because it was a donut shaped building and we had condenser gardens on the roof, that there's limited space, and we were going to need to do a lifted array. And the coordination with structural engineering to do that and the added costs, I just couldn't, and the payback ended up not being there, because we didn't wire the water heaters to the house meter, so we could have offset like a higher load on the house meter. So that was a big lesson learned, that I think if we had done it over, we could have gotten to net zero. Next slide. So just briefly, this is a scattered site in Antioch. It's 2 properties, 2-story wood frame, stucco exterior. And the number one issue was that it was the coordination of the owner, architect, and contractor. That was really challenging. Oh, I see. Somebody says not everyone knows what QAC is. Sorry, that in affordable housing, we have to do utility allowances. And usually we go with like a housing authority utility allowance, which is already set. And I don't know how they calculate it, but the QAC is an option in which they, energy consultants model what the actual usage will be, and then calculate what like an actual utility bill would be. And with an energy efficient building, in theory, it would be lower than the housing authority UA. So that's kind of high level what a QAC is. It is kind of newer terminology. I think not a ton of developers have used QAC yet. And I have some other thoughts on that in terms of lessons learned. We learned that there's 2 different rates that the QAC uses, a standard rate and a care rate, and so getting the care.
Before you go into that detail, though, it's 2:00 and Panama Bartholomew is on stack. So I think
Okay.
try to wrap up what you wanted to say about the challenges of the rehabs.
Oh, well,
it's a fantastic presentation. You've done a fantastic job.
Thank you so much.
Woo!
Yeah, so the house load was really small. There was no payback on the solar, challenges with the OAC team coordination, asbestos in the walls, and the cost to upgrade all the electrical systems. And I can just run real quickly through affordable housing trends. That's the next slide. You guys can just glance at this, is that yes, we're in an early adoption phase, but it's rapidly growing. I think like every developer has an all electric, and we're just getting on board. So that's very exciting, which means more data on comps is coming soon. People are experimenting with the variety of systems in their portfolio, so that when they are in operations, they can figure out which one they actually do prefer. And then there's a bit of a weariness on the foreign products, which is an issue because those usually are the most efficient. So that's a challenge that we need to overcome somehow, is get more of those foreign products in the marketplace so that they're more available. And then, yeah, lack of experience, widespread, but it's rapidly changing. And then I'll end on the next slide, which is my contact. Anybody have any questions? I'm so happy to network and link up, and would love to talk with you all. Thank you very much.